going to take what we learned in class one step further, and we're going to be solving polynomial equations. Now, we have been solving polynomials all year, but we've been looking at quadratic polynomials. Now we can look at polynomials of all degrees and solve them. And again, one of the methods for solving these polynomial equations is by factoring. So let's look at an example. Look, we've got a polynomial here of degree 5, and it says find the real and or imaginary solutions to each polynomial. So I look at it and I'm going to see if it's factorable. And there's a greatest common factor here of 2x. I notice, though, you want to be really careful. I noticed that it's not in standard form, so I'm actually going to put it in standard form before I do anything. I wrote that wrong. So 2x to the 5th minus 14x cubed plus 24x. Okay, equals 0. There we go. All right, so now when I take out that 2x, I'm going to be left with x to the 4th minus 7x squared plus 12 equals 0. All right, now remember I said you could divide by 2 to simplify the equation, but the only thing I want you to be careful of is really never divide by x, because when you do that, you're throwing out a solution, and we don't want to throw out a solution. All right, so in this case now, this is quadratic form, and so I can factor it like I do quadratics. They're just going to be of higher degrees. So here we'd have x squared and x squared. I want the factors of 12 that add to negative 7, so I think that's 3 and 4. Okay, and you could simplify this further and because it's dots, or you could just solve using the square root methods, which is what I'm going to do. So I'm going to set each factor equal to 0 and apply the zero product property. So that's going to give me 0. So I have a root of 0. I have a root of, so x squared equals 3. So x equals plus or minus root 3. So an irrational root. And here I'm going to get x squared equals 4. So x equals plus or minus 2. All right, so again, we have a degree 5 polynomial. It's positive. So we now know our graph, some things about our graph. We know that our graph is opening up, up, right? It's opening up, up. I have 5 roots, all of which are real, meaning I can graph them on the coordinate plane, on the standard coordinate plane. And my leading coefficient is positive, right? So that all these little things are starting to come together. My y-intercept is 0. Again, remember we said when we have a factor of x, then we're going to have a y-intercept of 0. And so you can solve it just like you would quadratic equations. All right, so I'm going to have you try number 2, and I'm going to go on to, on your own, and I'm going to go on to what we learned today, the sum and difference of cubes, okay? So we learned this new factor pattern. You guys did a great job with that today. What I'd like you to think about now is how are we going to solve it once we do factor it? All right, so let me go through the method again. I have 8x cubed minus 27. Several ways you could just apply the factor pattern. I like to rewrite them as cubes first to make it just a little bit easier, less cognitive load and me having to pull out things from my memory. So I rewrite them as cubes like that, and then I factor it. But remember, it's an equation, so don't drop the 0. If you drop the 0, you might forget to finish the equation and solve for x, which is what we're trying to do. We're trying to find the real solutions. All right, so if I use the difference of cubes, this would become 2x minus 3, and then 4x squared plus 6x plus 9. Okay? All right, now we talked about this in class. This is a linear factor, so I can set that equal to 0 and solve. Okay, so that's going to give me 2x equals 3, and then I'm going to divide by 2. So I have x equals 3 halves. But this factor is actually going to give you an imaginary root, so it's not factorable. I'm not going to use completing the square because it has a coefficient in front of 4. I just think it's going to be more complicated. So I'm looking for a more efficient or elegant way to do this. So I'm going to actually have to use the quadratic formula. Okay? All right, so I'm going to label my A, my B, and my C. Okay, and so I've got my a, b, and c. I'm going to plug them directly into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so x equals negative 6 plus or minus 36 minus 4 times 4 times 9 all over 8. Okay, so I have to simplify that. Negative 6 plus or minus 36 minus, all right, so 16 times 9, I think it's 154. I'm going to make sure, or 144, and it is. So 36 minus 144 all over 8. Now there's where that imaginary root's coming in. So now we have x equals negative 6 plus or minus the square root of negative 108 all over 8. Ugh, yuck, right? So let's keep going. I have to simplify the square root of negative 108. So remember, I've got to handle that negative first, so that's I. And then I want to simplify the square root of 108. All right, well, I know 9 goes into it, so I'm going to check 36. And I think 36 goes into it 3 times. So this becomes 6 root 3. So this becomes 6i root 3. I'm going to write it like that. All over 8. And then I can simplify those by 2, giving me negative 3 plus or minus 3i root 3 over 4. Okay, and those are my other 2 roots. Remember, we said that imaginary roots come in pairs. So when I had one root here, the other 2 both had to either be real or complex or imaginary, okay, or imaginary, because they were in pairs. And imaginary numbers, imaginary solutions come in pairs. Okay, we just did this by hand. You can also use your calculator, okay? So, but you can only find real solutions on your calculator. You can't find imaginary solutions because the calculator doesn't graph those, right? All right, so here we have a polynomial equation because we have our degrees here that we can see that makes it a polynomial. So I'm going to put it into standard form by subtracting. Okay, and now I'm going to grab my calculator. All right, here we go. I'm going to put that into my calculator. Let's see, I got something in there already. But I'm going to put in 2x to the 4th. I'm going to use the caret button. Minus 9 x squared. Yes, Coach Fred, look what you did. I'm going to start over. 2x to the 4th. Happens to me all the time. Minus 9x squared plus 4. And then I'm going to look at, I want to look at this graph. Let's see what we got going on here. All right, oh wow, I can see these zeros, can't I? And it appears that I have a 0 of 2 and negative 2. But there's a couple ways I can do this. I can go to my table, okay, and I can look wherever y is 0. So I can see right here that I have a 0 at 2, negative 2, and 2, okay? All right, now the other ones are, it looked like they weren't exactly on the axis, so that means they're irrational. So I'm going to go to a second, calculate, and I want my zeros. So I press 0, press enter. Now I want the 0 that's between negative 2 and 0. So I want to arrow to the left side of that 0, right about there, and press enter. And you can see that that triangle appears. And then I'm going to arrow up a little bit to the other side of the 0 and press enter. And now, do I want the calculator to guess? It's going to guess in between those 2 little arrows. And it's going to guess, and so I have a 0 at 0.71. Okay, or negative 0.71. I'm going to guess the other one is exactly the same, but I could go through that process again. Okay, all right, so I'd like you to complete the next one on the page. So both number 2 and then the example right next to this. We'll do number 4 together tomorrow. And then I assigned 2 problems on page 171, 51, and 52 in your packet. Okay? All right, guys, have a great day.